Welcome all of you. Today I am going to discuss about the very popular formula about arithmetic progression, that why the sum of 1 to n integers is equals to n into n plus 1 by 2. So I will give the proof by 3 different ways. So first way is very popular way, that let Sn equals to 1 plus 2 plus up to n, and Sn is equals to, I am going to write this in the reverse order, n plus n minus 1 plus up to 1, and this is equation 1 and equation 2, and I am adding equation 1 and 2. So 2Sn left hand side with left hand side is equals to right hand side with right hand side, and this is 1 plus n will be n plus 1 plus 2 plus n minus 1 will be n plus 1 up to n plus 1 will be n plus 1, and this will be for n times, because this is 1 to n, this is also 1 to n, so n times. So 2Sn equals to n plus 1 with n times, so n into n plus 1 implies Sn equals to n into n plus 1 by 2. This is very simple way. Second way is mathematical induction. In this method, we will show for n equals to 1 and 2 and assume for n equals to k, and prove for n equals to k plus 1. So for let n equals to 1, Sn equals to 1, so it can be written as 1 into 2 upon 2, which is equals to 1 into 1 plus 1 by 2. So it is the same way, that n equals to 1, so n into n plus 1 by 2. For n equals to 2, Sn equals to 1 plus 2, which is 3, which is equals to 2 into 3 upon 2, which is equals to 2 into 2 plus 1 by 2. So it is the same way, that n into n plus 1 by 2. Now we will assume for n equals to k. Now assume that the sum up to n into n plus 1 by 2 is true for n equals to k. So for n equals to k, 1 plus 2 plus up to k will be k into k plus 1 by 2. Now we will prove for n equals to k plus 1. For n equals to k plus 1, the sum 1 plus 2 plus up to k plus k plus 1, which is 1 plus 2 plus up to k plus k plus 1. But by this we know that the sum of k integers will be k into k plus 1 by 2. So plus 1 into k by 2 plus k plus 1, which is equals to k into k plus 1 plus 2k plus 2 by 2, which is equals to k into k plus 1 plus 2k plus 1 by 2, which is equals to k plus 1 will be common out, so remaining will be k plus 2 upon 2. So this is the formula that for k plus 1, for n equals to k plus 1, k plus 1 into k plus 1 plus 1 upon 2. Mathematical induction proves that for 1 plus 2 plus up to n, the sum of 1 to n integers equals to n into n plus 1 by 2. And the third method is by the formula. As we know that the arithmetic progression Sm is given by n by 2 into 2a plus n minus 1 into d. We can also expand this n by 2 into a plus n minus 1 into d. Here a is first term of the progression, which is equals to n by 2 a plus arithmetic progression. Nth term of the arithmetic progression is given by a plus n minus 1 into d. So this will be nth term, which is an, or we can say that an equals to l. So the formula is n by 2 a plus l. We have to find the sum 1 plus 2 plus up to n. So n is n, nth term is also n, which is l equals to n, a equals to 1. So Sm equals to n by 2, 1 plus n, which is equals to n into n plus 1 upon 2.